Welcome back. In today's session, we are moving from beams to vertical structures as we take a detailed look at column reinforcement in Auto C.A. Whether you are dealing with multi-story projects or complex cross-sections, mastering vertical bar distribution is essential for structural accuracy. In this tutorial, I will guide you through reinforcing a 3-story column, from setting up the starter bars and the overlaps to implementing smart stirrup configurations. By the end of this video, you'll be able to handle complex column geometries with the same ease and efficiency as our beam workflows. Let's get to work. Today, we will reinforce a 3-story column, like for example a 30 by 30 centimeter cross section with a central rhombus stirrup. I define the first starter bar from the bottom. For that I'm gonna use this shape. I will set the cover, which will be 3 centimeters. I'm gonna need to rotate this bar 90 degrees. We need both bars, both the inside and the outside bars. And I'm gonna complete these yellow brackets, which are necessary. So I'm gonna insert one bar with a diameter of 14 millimeters. Let's create my bar. First, I'm gonna place the inside bar, which is gonna be somewhere over here. With these buttons, I can change the orientation of the bar, and I can set the hook to be up or down. I need it down. And of course, the insertion point can be set to here. So I'm gonna need a helping line, put it over there. After that, I'm gonna put it where it belongs. I place the outside bar here to increase the scale. Yes, this is the outside bar and this is the inside one. I'm gonna copy this one, the copy elements function, to the other side as well. Move it back with 6 centimeters. Alright, we have the starter bars. Now I create the top straight bar with a new definition. This is gonna be a straight bar with the same parameters. Let's create it. Need it here. And I take care to ensure a 60 diameter overlap where the starter bar meets the longitudinal bar at the base of the column. So 60 times 14 equals 840. So we need 84 centimeters of overlap. That's why I stretch our starter bar with 31 centimeters. As you can see, I only stretched the inside bar, but the outside bar got stretched as well. So we have the overlap. Now we need to increase the size, the length of this straight bar up to the second floor and even more to have an overlap here. Well, exactly 84 centimeters. And now I need to mirror it to the other side as well. So I'm going to use the mirror elements proprietary Auto C.A command, and I'm going to need to define the middle of the column first. Now I can mirror it, okay, and delete elements of source. The default is no, so press space, and there we have it. We need to move the starter bar back a little bit, but yeah, this is it. Now I can create the bars running the full length of the column in one piece, then split them using the break bars function. So first let's take a measurement. How long of a bar should we make? This is 550. I used this button where I can put down a measurement onto the drawing, and the exact value will be taken over. So 544 is the exact length together with the cover. We will need one bar of 14 millimeters in diameter. So we can basically put it down onto the drawing. I'm gonna put one here. This is sidebar, and the outside goes there. Awesome. Now we need to break it. I'm gonna choose this break bars command, select the bar, click the overlap option, or simply type V into the command line and press space. And now we need to type 84 as the parameter for the overlap. Space again. And now we need to specify the breaking point. So I'm going to click on this corner. And now we have two pieces of rebars. We just need to stretch the overlap a little bit, just like this, 2 centimeters. Okay, now we have another overlap just as we need. Okay, the last thing to do, mirror these two bars, two inside bars, the other side of the column. Okay, there we have it. Oh, and one final step is to create a hook at the end of this straight bar, like 25 centimeters. Should be okay. A little relocation for the bar, sidebar, and that's it. Now I change the scale back to 1:20 because we're gonna draw the cross section. So I'm gonna start with the formwork. As I said, this is gonna be a 30 by 30 centimeter column. Let's change the layer. Okay. Going back to the scale, this detail checkbox allows you to change the scaling mode. Pressing the model button changes the geometry size if you change the scale, while the layout button scales the text when you change the scale itself. Even a small tooltip helps you choose the correct mode when you hover over these two buttons with your mouse. For more details, see our specific tips and tricks video on this topic. Okay, let's go back to the general scale. We just created the section. We need to define the stirrup, which is under the stirrups menu conveniently. We need to define the real cover, which is gonna be 2.5, sorry, 0.5. Okay. I'm gonna click on this mirror button to have the hook on the top left side, in the top left corner. And now I need to set the sides with this button I showed you earlier with the straight bars. You just click on them and define the length on the formwork. So we have 25 by 25 as the stirrup sides. We need one stirrup for now with an 8 millimeter diameter. And let's create it. First we need to put down the inside bar, then comes the outside one. Okay, let's put a call out on the inside bar, on a bar, on an inside bar. Create call out, select it, space, create a line, space again. That's how you do that. And now we know that this inside bar belongs to the bar number 46, which has 8 millimeters as diameter. So this is the outer stirrup. Now let's look at the inner supplementary stirrup. In this case, our job is easy as the cross section is a symmetrical square. We simply copy the existing stirrup, both the inside and the outside ones, rotate them by 45 degrees, okay. Place the inner bar in the section, modify the size. Let's try with 18 by 18, be a little bit bigger, 19 by 19, okay. And we are done. We can add a callout to this one as well. And now we have both the outer and the inner supplementary stirrups. Now, as you can see, currently there is only one piece of each bar because no distribution has been applied yet. It is important to note that Auto C.A works most efficiently when the program derives quantities from the distribution rather than manual entry. Now, this is the most complex part of the program, which is actually quite simple. You must link the these stirrups, to a column distribution and the longitudinal bars to the section bars. This is how the program calculates precise quantities. And we use the modify command to achieve this. And note that for column reinforcement, as in all other cases, these elements functions as macros, all these entities. So they are freely modifiable and reusable at any time. Now, I'm gonna create the 3-zone stirrup distribution. And I'm gonna select the segments directly from the drawing. So we need to define all 3 segments on here. The first segment is gonna be along the overlap, and the other segment is gonna be counted from the bottom of the beam where we need to arrive with our distribution. So it's gonna be 60 centimeters from the bottom. So these are my 3 zones. Together with a little plus, we need to put a few stirrups into the foundation as well. So plus 16 centimeters. Okay, so here in the Auto C.A panel, first, very important to link our distribution to our bars. So I use this button with 3 dots and select the side of our outside stirrups. That's 1. This is 46. Now I click on the add position checkbox and again on the 3-dot button and select the side of the inner rhombus stirrup. Now we see that we have 2 links to the 46 and the 47 mark. Okay, now we can select the distance, so we can enter the 3 segments of the distribution. The first one is going to be a 10 centimeter spacing between the stirrups. The distance is going to be defined with this button from here all the way to here. That's 100 centimeters. The middle segment is going to be distributed to 15 centimeters. The length is this one, 126, and the last one is back to 10 with a length of this. Okay, 110. We need the generator line. We need to force the extremes and the real view. And that's basically it. Now we create the bar series by selecting this point. Okay, more like this point here. Here exactly. We need to define the vertical orientation, and the horizontal one. And the rest is done by the software. That's right. Now we have the distribution with all these spacings we just defined. Let's move it to its place. Okay, something like that. And let's create its call out so we know where those segments are. Create call out, bring it here. We need to increase its scale. Insert a bigger scale and click on this arrow button. Select the object you want to scale and press space. That's how you increase scale. Okay, now we have completed one vertical column stirrup distribution. Now let's check back onto our cross section. I'm gonna relocate outside stirrups because our callouts got bigger. We have now the distribution distances 10 and 15 displayed here, but we can further modify these callouts and add the total bar of the series, the total bar count. So now we know that in this floor, for our column, we need 31 stirrups. So yeah, now we know that we have all these things connected together. You can also check the connection between the elements by going into the Modify menu, select one of your outside bars, and on the panel up here, you can click on the Enable or Disable the Zoom position. So now we see physically the links between these elements. So if you see this and if you can update the quantity of the bars, then it means you worked right. So good job. Now we need to do the same with the longitudinal bars. We need to distribute them into the cross section here. For that, we need to use the bar section menu, the control panel. We need to select the aligned type. We will need the generator line, the real diameter, and the full circles. Very important, we need to link the outside bar. This is gonna be the starter bar, add position, and another longitudinal bar up to the first floor. So there we have the linkage. We will need to force the extremes. We will need to change the external generating position to on axis. So that's how I like to use it. But you can use freely any other presetting. Now let's create the bar section. We need to change the bar number. It's gonna be 4. And now we can create the bar section series. Click on the button and select position for them here and here. And I said it wrong because we only need 3 bars on each position. Okay, so 3 bars on each side. That means that we need 2 more. And we can do that by copying this distribution. Copy it here and change the parameters back to 2 bars and add modification. Now as we check back to the longitudinal bars, you can see that we have 8 bars of 14 on both of the outside bars. So we have 1, 2, 3, 4, 5, 6, 7, and 8. So that's right. This is how the program calculates very easily and rapidly the bar quantities. This is why I said that you really shouldn't do anything manually. Just let the program do the hard work. Alright? And now to finalize this cross section, we can also use callouts on the bar sections. This is the type on the bar section and on a linked bar, because these bars indicated with the magenta generator lines, these are linked to outside bars. So that's why we need to use the callouts with on-linked bar option. We will need the number of selected and the diameter. Let's create callout and select each bar, space, draw a line, and space again. Let's change back the scale, and that's right. We have all the bars measured and equipped with callouts. We have the 42 and 43 marks here, which is right because they are linked to the bars number 42 and 43. That's all right. Now let's put a little symbol here. I'm gonna create a little mark for the cross section, indicating where I made this section. Perfect. Now you might get a little bit confused with all these inside and outside bars and which counts as which do not count. Let me explain the difference between copying stirrups versus inside bars and section bars. The key is that the primary element is always the outside bar, these blue ones, which is what the bar schedule counts. This is the bar schedule or the bar table. If you select everything, the thing is that only the outside bars gets counted into the bar schedule and the total weight. This is why these are the primary elements, the primary entities of Auto C.A. The inside bar and the inside stirrup are often only for display purposes. However, the inside distributions, the bar series and the bar section series, are internal bars that increment the quantity of the outside bar if they are linked, as I said. Therefore, if you only copy the outside bar, like this one, you get a brand new bar that counts as one piece. It says 8, but that's just because the original one had the 8 as well. But in reality, it has no link whatsoever. So it's just taken the amount from the original one. But I can rewrite the number of bars anytime I want. So that's gonna be 1 again. If I copy an outside stirrup though, then this is gonna count only 1, as you can see here. So that's it. If you only copy the internal bars, the copy element, this is proprietary for Auto C.A. So it shouldn't be confused with the simple AutoCAD copy. So whenever you want to make multiple entities of the Auto C.A. type, you need to use this one, okay? It's very important. So when I only copy the inside bar, the quantity won't change because the inside bar isn't counted. If you copy the inside bar distribution though, then the number will change. Now it's 62. If I delete these, then they will go back to 31, yeah, as you can see. And if we copy both of them, both the internal bar series and the external stirrup, then I'm gonna get a brand new stirrup with the same amount as the original, because now we have a new link between these two. We modify the outside stirrup. You can see that it's not linked to the original bar series, but the new one. So we can say that the links don't disappear with copying. So you can keep that in mind. Now that we understand the core properties of copying, let's continue with the column. By using a properly selected reference point, we can capture all existing bars and copy them one floor up. We need to exclude the longitudinal bars and the polylines selection, also the side longitudinal bars. And yeah, we have everything selected. And now I'm gonna choose this point as a reference point. Okay, and I'm gonna move everything up one floor. And this allows us to reinforce even massive multi-story columns very, very quickly. Okay, we just need to clean up the things a bit, like we need to stretch this distribution up and also down a bit. This one comes up as well. It's all just stretches. You can reshape all your bars and all your distributions as you like, because there's almost no limitation in that. So if you are not really familiar with the stretch function yet, I highly recommend to get familiarized with it. So these are the distributions fixed. Now we need to fix some straight bars, because I see that I did a mistake there by copying everything. Want to do that. Now, as you can see, we are just deleting the outside bars, the longitudinal bars, but the bar sections are now missing as well. That's because of the link between them. Let me choose 1, 2. Okay, and now we can copy the section bars and reassign them to the proper longitudinal outside bars. Let's copy everyone here, space, select a reference point and bring them up a level, and again up a level will be the top floor. Now if we check the first bars, we see that these count 24 bars. It's of course not okay, so we need to reassign these bar sections. Modify, select everything, press space, press modify cross section, section bar, and in the link outside bar option we need to check the box, select with the 3-dotted button new outside bar. Now we have 8 bars for the 44 mark and less bars for the 42 and 43 ones. Okay, and again let's do the same with the top floor. Link to outside bar, click on the point, 3 dots, and now we have the 45 bar linked to these cross sections. 45. It says the callout. Now we have only 8 bars everywhere. This means that we did a good job. We can update now the bar schedule by modifying it, and with the plus icon selecting new elements be inserted and modify. Now we can see all our stirrups and longitudinal bars listed, and the total weight is 189.35 kilograms. And this is it. If you have multiple columns of the same size, exactly with the same measurements, then you can do this. You can change the longitudinal bars, the long bars, parameters here in the number of groups section. Let's say we have 4 of the same column press enter and modify. Now if we check the labels for the bars, we see a 4x multiplier, and we need to do the same to the stirrups as well, only to the outside ones. Search for the number of groups, enter 4, and modify. And we see the same 4x multiplier next to the outside stirrups as well. And if we check the bar schedule, select it, right click, bar schedule Auto C.A, update bar schedule, and now we see 4 times the weight. But what if you have different sized columns? Then we can copy everything, all structure, space, reference point, relocation. Need to wait a few seconds. And now we have another assembly. And if we want to increase its size, we can do this. We just need to use the stretch option. And I'm gonna select this whole column in a way that my lasso cuts through the middle of the column. And I do the same with our cross sections as well. Now I press spacebar, pick a reference point, and I want to increase this column to 50 centimeter in thickness. So let's increase its side with 20 centimeters. Press enter, wait a few seconds because it needs to process a lot of things. And yes, we have our new length for the column. We just need to put the distribution back to its place. Okay, all right. Relocate callouts. You can see them easily. Nice. And now we need to think about the inner stirrup, because now we don't need the rhombus shape. We just need another rectangle inside the bigger rectangle. So for that, we just need to rotate again the outside stirrup by 45 degrees and the inside stirrup as well, 45. Let's increase this side to 25, bigger one, and the other side can remain as is. The only thing we just need to do is to increase the number of bars on these two longer sides. So this will be 4 and 4, the other side as well. And that's it. There we have 4 columns, because we still have the multiplier. 4 columns with 50 by 30 centimeter cross section. And we can basically do the same on the other cross sections as well, but you get the point. We can check the bar schedule again. There we have a little bit more of a total weight, but that's obvious because we increased the size of the column. Now let me just copy everything once again. Yes, and I'm gonna create a big bar list, everything inside, just like that. Now I'm gonna use something called element assign. This is basically a filtering where you can assign specific entities, mainly outside bars, to a group, which I'm gonna create now. I'm gonna create a new category named columns. Okay. And inside the columns, I'm gonna create a new element, which is column 30 by 30, and another one named column 50 by 30. Okay, again. And now I'm gonna assign my already selected elements to its respective group, which is columns 30 by 30. And we will immediately see the change in the bar tables. because we will see the naming of our column 30 by 30, and even in a bigger one we see it. We have ungrouped elements which appears here, and we have our group, the column 30 by 30, which has this amount. And I can do the same with every other column as well. This is a 50 by 30. You can see that now the bar schedule has just got updated, and we can assign these two as well to the 30 by 30. I know this is a 50 by 30, but I did it wrong on purpose because I want to show you the reassignment as well. So we need to update the bar schedule manually this time. Yes, we have 30 by 30 and 50 by 30, but I assigned this to the wrong place, so I need to just select again and reassign to the right place, the right group. And that's it. We have divided all this big bar schedule into two parts, being the 30 by 30 and the 50 by 30 columns. And that's it. Now we see that this bar list is very, very long. But we know that we have similar bars unlisted. So if we want to decrease the size of the bar list, we can just type group positions into the command line, type S to select bars, select all the columns, press space, check the checkbox, use the lowest value automatically, click OK, and now we will get grouped numbers. So every identical bar will get the same mark number, and this way our bar schedule can be updated and can be shortened a lot. So you can check the bar marks: 42, 43, 44, 45, and it's the same here. Yes? So that's how you can group the bar positions. So this is basically it. That's how you can very quickly reinforce massive multi-story columns. But keep in mind, if something seems too complicated during your workflow, you are likely not using the most efficient method. Feel free to contact us and we will be happy to show you the correct way. And that wraps up our tutorial in column reinforcement. We've covered how to efficiently handle vertical bar distributions, manage overlaps, and use the modify and element assign tools to keep your projects organized across multiple stories. Remember, the power of Auto C.A lies in its macro-driven logic. Once you understand the relationship between your host bars and their distributions, you can save hours of manual work. If you have any questions or run into a particularly tricky detail, feel free to reach out. We're always here to help you optimize your workflow. Thanks for watching and see you in the next one.